Yes. So now let's say same 200 photons are transmitted through, let's say 15 centimeters. What would the answer be then?
25.
Everybody get it?
This has to do with like part.
Yes.
This is not just.
All they're doing is they're just
No.
doing 200 divided by 2.
Very good.
Basically,
And so this
the
is
answer would be 100.
your previous question. You're like, why does it matter if KP mass? That's like,
10
is
centimeters.
unchanged
Oh,
There's
Right.
because of
25.
this.
Yeah.
You know what I'm saying?
So
Depending on how
and then
thick a
another
piece
half
of
will
this,
be
it will
50.
change your
Yes.
second.
See, but that's what I was saying, like, and change from based off of what, like.
Just the big, like you shoot everybody, for example, like 70 kVp, like 4 mass. Everybody gets shot the exact same. How would that differ? You know what I'm saying? Like, how would that differ with patients? You have a baseline for all 4 body habits.
So it's not like when you type in the exam and it comes up and it's already, you just go.
Yeah, because I don't know if you've noticed, but on the control panel, they even have 4 body types that you can pick from what they look
Yeah,
like,
oh yeah.
and it'll adjust it.
Oh yeah, that's
So,
okay.
yeah, that's why that
Okay, that
happens.
makes sense, that makes sense.
Okay.
All right, Muncie.
Gain absorption and attenuation further contribute to.
A bit louder. A bit louder, please.
What was it?
Oh, just a bit louder, Muncie.
Oh,
Thank
he
you.
said speak louder.
Yeah.
Okay.
Differences in absorption and attenuation are primary factors that contribute to
Differential absorption.
differential absorption.
Yes.
All right.
That's true. Because if something's getting absorbed, how would that look on the IR, right? So like, let's say, I don't know, I have like 20 centimeters of tissue, and then my KVP is really low, it'll all get absorbed and almost nothing will go through. So on my IR, it'll look black or white, depending on how much.
White.
Exactly, right? So, I don't even know. Oh yeah, yeah. And then if it's transmitted, then it's gonna come out black, right? So the differential of absorption, it's like how much is transmitted, how many like is absorbed, will give you those different colors of black and white throughout the image.
Right. So most obvious example is the chest, right? Because in your chest X-rays, part of your chest looks black, part of it looks white. What part looks black?
Lungs,
Lungs. What part looks white?
bones, ribs.
Bones, ribs, spine, right? Why did the lungs look black?
Because there's transmission there, sir.
Because there's more transmission.
There's more air.
Right. Why does the spine, why did the ribs, why does the heart look more white?
They absorb the.
There's
It's
bone
absorbed.
that has higher atomic.
Right, so higher atomic number or more
Higher
tissue
absorption.
thickness or more density, right? So there's more absorption there. So different types of tissue absorb X-rays differently. That is what gives us our image, differential absorption.
Everybody okay on this? No questions?
Sort of.
Okay. Okay.
The size
Oh.
it's the same one, right? Yeah.
Right, let's just make it.
If it's unchanged, which of the following foods? Oh, it went through, okay, so. Asthenic, Mr. Phung size?
Yes, sir.
Okay.
That's how I have to remember.
You look at him.
I did, and he caught my vibe.
Everybody understands this, right? It's just like the other ones, but
Didn't
just,
it?
we're not looking for absorption, we're looking
Yeah,
for
cause it went through. Okay, I know a little something, yeah.
Okay.
If the primary beam interact with the air, what is most likely to occur?
Louder, Cindy?
If the primary beam interact with air, what is most likely to occur? Interact with air.
So if you just look at your answer choices, you can see that 3 of these out of the 4 have similarities to each other.
So transmission, absorption, and scatter have similarities.
So, for example, like I said, if a lot is being absorbed, how would my IR look? Like bone?
It's
You know,
gonna be
bone
white.
absorbs white, right?
Yeah.
So absorption will turn the IR white, so you can, you're like, those are kind of similar. And then if there's more, if there's like if there's more thickness, right? And then that also increases scatter, right? And so you can see the transmission is the only one that's kind of different than the other ones. You understand kind of?
Transmission.
Yeah.
So absorption,
Everybody get this?
Yeah.
and
Okay.
scatter.
I don't know how to rule out scatter though.
Scatter? Well, like,
How do you rule out
there's
scatter?
less, okay, let me ask you this, where is there more scatter, like, traveling through 10 centimeters of tissue or going through air? Because what increases scatter?
Probably density increases.
Density, thickness,
I see, so that
Right.
I see, so this scatter is ruled out because
Yes.
water is not that dense, it will transmission.
air is not that.
Air, the transmission.
Yep. An image is taken using a CR cassette. The image seen on the display is the blank, which is the product of the blank being processed. The image we see, I know, is the manifest image. So let's see. So that just brings us to, let's see. Manifest image
You
and
basically got it right already.
yeah. Let's see, product, this was the manifest image and, oh yeah, and the Latin image is, you know, it's processed, yeah.
Everybody understands this one?
First is the latent, or first is the manifest?
Well, see, it's the way I
It's the
flipped it.
other,
Manifest is.
oh, it's the other way.
Latent is the first, but I
Right.
flipped it.
But in this one, the first answer is manifest and the
Yes.
thing is.
Because, for example.
Which
I'm
one
using
was
the-
it? I'm
So the
This
manifest.
cassette
It's the
right here.
manifest first? Okay.
I'm using this cassette right here.
I just want to.
You know, I put it in the bucky, boom, I get the x-ray. I take it out, what's sitting in here?
The latent normally,
The latent, right?
but
But see, here I asked, what image is seen on the display? After I scan this in and you see like,
on the display you're seeing the
Yeah.
manifest first.
exactly. You got it, you got that.
Any questions here?
Okay. Cody?
High contrast has a blank correlation to contrast resolution.
Oh, I don't actually know if we've gone over contrast
Oh.
resolution yet.
Yeah, we did. Contrast, yeah, we did. We did spatial resolution, contrast resolution.
Oh, did we? Okay.
Yeah, with the shades of gray, yeah.
Alright.
I would say it's direct. It's either that or
So-
positive.
So, what does high contrast mean?
It's more white.
More white and black, right? Bigger,
Okay.
like completely black and completely white is
Okay.
high contrast. Low
Okay.
contrast is kind of like some shades mixed in with blacks and whites,
Okay.
right? So if it's high contrast, if it's just black and white,
Yeah.
those are the only two colors. What does that do to contrast resolution? Because the amount, if you have more shades of gray,
Yeah.
what does that do to your contrast resolution? Increases, yes, correct. So if you have only black and white,
Yeah.
what does that mean to your contrast resolution?
It's less.
Exactly. So it would be negative, of course.
Okay.
That's why it's a little
High
confusing.
contrast would be
Light.
positive and less contrast would be negative.
No.
No.
No, it's the other one.
So contrast, right? High contrast is black and white.
Right.
Yes. Low contrast is like
Is
black,
gray.
white, grays, right? So, and then contrast resolution is like the more shades of gray you have in an image, the higher your contrast resolution is. So that means high contrast has an inverse relationship with contrast resolution. It would just be kind of confusing, right? You think, oh, high contrast resolution. No.
If the contrast is high, then resolution is low.
Mm-hmm.
Yes.
So
Correct.
then that's why it's negative.
Because high contrast resolution is usually like no grays. Contrast resolution, you want more grays to increase it.
So you said high contrast and, contrast resolution has a inverse
Yes,
relationship?
inverse, negative.
Negative,
Yeah.
okay.
High contrast.
And so like, see, this one, also you could have, kinda like, used the anti-droids to your advantage, cause direct and positive are pretty similar. And then, no, it's pretty much a 50-50 every year. So it's always good to like, make sure you look at your answers too. Sometimes it'll help eliminate.
High contrast and resolution and inverse relationship.
Yes. And shades of gray with contrast resolution has a positive correlation. Okay?
Carla.
Which of the following would not increase scatter?
Yes. So, I wasn't here when you talked about that.
Right, so one of the properties that we talked about is that with atomic number, it affects absorption, but it does not affect our Compton scatter. Right, atomic number affects photoelectric absorption, but it does not affect Compton scatter.
Wait, I thought you said atomic number affects attenuation.
Yes.
It does affect attenuation,
This is
though,
scatter.
because attenuation is made of what two things?
Scatter and absorption.
Scatter and absorption, right. So if
It affects
absorption goes
absorption.
up, attenuation goes up overall.
Oh,
It's
okay.
Mr. Phung, is it not affect scatter because no, like, it interacts with the outer shell?
Mhm.
Okay.
Yes, raise it.
I thought, atomic number and like the part thickness go together.
They do not. These are all separate things. So atomic number,
Not thickness, but
part
what about
thickness,
density, right?
and density. All three are separate. All three are individual variables. Right? Atomic number can increase without thickness or density increasing.
Oh, okay.
Thickness can increase without atomic number or density increasing. Density can increase without atomic number or thickness increasing. All three are independent of each other. There are three independent variables we need to consider.
And here's another good example where you can use your answer choices to help you get the right answer, because we know for sure increased tissue density. This is what we talked about earlier, right? The compactness, that will increase scatter, and then so will the thicker the patient is, the more the scatter increases, and then if you increase KBP, that also increases your scatter.
But if the thicker the patient, the more absorption, then how can there be more scatter, sir?
Because it's bouncing around.
That's right. So the thicker your patient, more interactions are likely to happen, correct? The more, so what kind of interactions can happen?
Absorption,
And
also scatter will be, if
Scatter.
absorption is increased, scatter will also be increased.
not necessarily.
But there's a chance.
In the case of tissue thickness, because you have more distance to travel through, you have more chances to interact with stuff. When you interact, interaction could be absorption, but it could be scatter, right? But both of them can happen. So increasing thickness increases the chance of stuff happening, increases both absorption happening, increases both scatter happening.
Also transmission. Also increases transmission.
No, transmission is the opposite. Transmission is nothing interacting. As it gets thicker, more chance of it interacting, less chance of it not interacting. They're opposites, right? They cannot both be true. They are opposites. Attenuation and transmission are opposites.
These are actually mind twisters.
They are not. They
This
should
one's
not.
like, just wait till Wednesday.
This is
They should not.
back down to the.
Veronica.
If there are two images taken, and image one has a bit depth of 4, and image 2 has a bit depth of 2, what change has occurred between 1 and 2? Lower
Is that the form of
spatial
approval?
resolution?
What's up?
Is it lower spatial?
Spatial.
Yes.
Because you have less bit?
Yes, so
No.
wait, hold on.
Contrast,
Yeah, yeah, it does look, oh wait, what, did you say spatial?
Yeah.
Oh, no.
So contrast.
Yes. So again, bit depth gives you how many what?
Shades.
No, not pixels.
Shades of
Shades, yeah, shades of gray, right? Bit depth, shades of, it's important you guys get bit depth is with shades of gray. And pixels is like matrix, they're separate, they're not, don't combine them. And so, spatial resolution has to do with your matrix and pixels. Contrast resolution has to do with the bit depth, number, shades of gray, okay? Don't get them mixed up, cause Mr. Phung will put some questions like this
So
together.
higher contrast resolution is now
So in image one, how many shades of gray do we have?
2 to the power 4 is 16.
Okay, and then image two, how
Is
many?
4.
So in image one, we have 16 different shades of gray. Image two, we have 4 shades of gray, right? So it is decreasing. It's going from 16 to 4. Yes?
So high
So that means, and then the more shades of gray you have, the higher contrast resolution you have, right? The lower is the less contrast resolution you have, right? So if it's going from 16 to 4, what's happening to your contrast resolution?
higher
Yeah.
contrast resolution.
No, lower, because it's
The
going from
comparison
16.
is high, right? For
What's up?
if the comparison is high, when it's
No.
from 14
No, 16 to 4.
to 16 to 4 is high.
So, Shaheen, how many colors are you starting with?
16, sir.
How many colors do you end with?
4.
Do you have more colors or less colors?
Less colors. Sir.
So if you have less colors, what happened to your contrast resolution?
It reduced?
It reduces.
Oh, I see.
Very good.
So lower contrast.
The lower contrast. Oh, I see, sir.
Does anybody?
How does this affect the high contrast, the one with that question earlier?
Well, which one?
That negative,
Oh.
that is already.
So, yes,
Uh,
so in this case, if instead of contrast resolution, it was asking you about just contrast itself,
It'd be higher contrast.
then it would be higher contrast.
So therefore,
He's not gonna ask that probably. Not on this one, maybe on the next test. That one's more.
Have you made the test yet?
No.
What's from last year?
I have the one from last year.
But you don't use those ones.
I
Don't
tempt
updated
him.
questions.
I've had a lot of
Too
others
harder?
today with stuff on.
Harder?
I updated questions.
Uh,
That's all. Not harder, not easier, just
From 16 to
updated.
4
yes.
shades of gray,
Mhm.
and then, you're saying that.
So 16 would
4
have.
shades of gray, so you have lower contrast resolution because you only have 4 colors compared to 16 colors.
Exactly.
Mhm.
So contrast resolution is low, but then,
Contrast.
oh, and because of that, like, it's, you can't see that much, it's not as visible,
Yes.
the picture's not visible.
Exactly. Uh-huh.
So you have a low contrast,
Resolution.
No, so you
No.
have high contrast.
high contrast.
Because you only have 4 colors now. So the
Oh,
jumps
yeah.
between each color is going to be big. Right? It's not going to be going from dark gray to slightly light gray, right? You're going from black to dark gray to light gray to white. There's no in between, right?
Exactly.
Big jumps.
So because I felt that was a high contrast. Sir.
So that's high contrast.
But then what is
So
now? How is it different
So
from low
the
contrast?
less
I'm almost there, Shaheen.
Bit depth,
Mhm.
the lower the contrast resolution, but the higher the contrast.
I'm
So
lost.
let me
Can I say
share.
something?
Yeah.
Tara, go.
Go ahead.
So, basically,
Yeah.
lower bit depth, higher contrast, lower contrast resolution, correct?
No. No.
That's wrong? I said lower bit.
Oh,
depth,
yes, yes, yes.
Lower contrast resolution, higher contrast,
Yes.
correct?
Yes,
Yeah.
That's correct.
Yes, sir.
Higher bit depth, right?
Mhm.
Higher contrast resolution,
Yes.
lower contrast,
Yes.
correct?
Yes.
Thank you.
All
You got
right.
it.
Chara.
Yeah.
So let's go back over this one more time why resolution versus contrast are different.
Thanks, sir.
So let's say that we start off with a high bit depth, so we have a lot of different colors. And then let's say we go down to a bit depth of 1, either black or white, right? So if we take a picture of the abdomen, right? And we only have black and white, is it obvious where the air is going to be?
No.
Yes.
Yes,
Yes,
because
I
the air is
think
going to be what color?
Black,
Black.
sir.
Is it obvious where tissue is going to be?
White.
Yes, because tissue is going to be white, right? So high contrast, big difference, right? It's either black air or white tissue, no in between. However, inside the abdomen, what kind of tissue do you have? You have bone, you have muscles like your psoas muscles, right? You have soft tissue like your kidneys, you have soft tissue like your liver. What color will they be with your 1 bit depth? They'll all be white, right? You cannot tell the difference between your bone versus your psoas muscles versus your kidney versus your liver because they are all white. Why are they all white? Because you don't have enough colors to make them anything else. Your only options are white or black. You can't make them black, that's air. So they can only be white. So high contrast, big differences, but low contrast resolution. You can't show small differences. Right? Contrast resolution is the ability to show small differences. Now, let's go back to our really high bit depth. Lots of gray colors. Now, bone is going to be brighter, right? It's going to be a really light gray, really close to white. Your psoas muscles are going to be kind of a dark gray. Your liver is going to be a slightly lighter gray. Your kidneys are going to be a slightly darker gray. So now of all these different colors, you can tell them apart, right? So you have contrast resolution. You have higher contrast resolution. You can tell them apart, even though they're slightly different. But now the changes in gray are very small, right? You can't tell very obviously where one gray starts and the next gray begins. So your contrast is low. So high resolution, low contrast when you have a lot of grays. Low contrast resolution but high contrast when you only have black and white. Right? That is why they are opposites. Does that make sense? Or do we need a more visual example? All right.
I get it now, but I know how to tell.
Oh, you're gonna. Just remember, guys, that the more the higher the bit depth, the more shades of gray you're gonna have. It's in the formula, 2 to the n, right? So, and then the more grays you have, higher.
You see how you have more colors with low contrast? So you can see different levels of how light it is.
What do we have?
A chest.
Great. Where's the ear?
Now this is
All right. Where's the tissue?
all the whites in the tissues.
All right. Great. Where's the heart?
In between the lungs, there could be there, sir.
Here? Okay. Well, where's the spine?
It's kind of there, but
Where does the spine start and where does the spine stop here?
I don't know.
Right? I don't know where the spine starts and stops here, right? Why not?
Because higher contrast.
Because resolution is less,
Low
contrast resolution is less, so we cannot tell the difference, sir.
Okay. So, how about gradient in your words? Why can I not find the edge of the spine here?
Because the contrast is high, but the contrast resolution is low. What's the, oh, and then, so that means the bit depth is low.
Very good. So the bit depth is low, right? Only black or white. So our resolution is low. We can't tell the difference, right, between where like the spine is supposed to start and stop, right? But when we do see a difference, right, between tissue and air, the difference is very obvious, right? High contrast, but the resolution is low, low contrast resolution. Okay? If we take this to the other extreme, right? So now, a lot easier to see the spine, right? Okay, we can see the heart shadow now, right? We can see like across different angles. We can even see breast tissue right here, right? So we can see all of this different tissue now because we have different shades of gray to work with, correct? Right? We can see ribs, right? We couldn't see ribs earlier. But is it obvious the difference between like, let's say air versus the ribs versus the soft tissue versus this soft tissue versus that soft tissue? is the difference as big anymore? No. The difference is much smaller between our colors now. So, high contrast resolution, but low contrast. Lots of colors, you can show lots of different structures, so high contrast resolution. But the difference between the colors is small, so it's a low contrast. Does that make sense?
Yes.
Okay, so lots of colors, high resolution, low contrast, very few colors. Right? So very few colors, low resolution,
High
but
contrast.
high contrast. Okay? So it's just the difference between how many colors you have and how easy it is to tell these two colors apart and how easy it is to tell multiple things apart.
What was low resolution? You said the colors, what?
Right, so low number of colors, right,
Oh.
just black and white. So low contrast resolution, but high contrast.
I remember our class also struggled with this.
You know, it's tricky. It's tricky, it takes time, it does take time.
Okay, guys. Real quick, just recap, bit depth and grays have to do with which kind of resolution?
Contrast.
And then pixels and matrix?
Spatial.
Perfect. Make sure you guys know that.
Pixels, matrix, and what's the third thing?
FOV.
FOV. And what does FOV stand for?
Field of view.
Field of view, very good.
Charlie?
Somebody already answered that.
Huh?
That's a repeat.
Oh, is it? I don't think it is.
yellow.
It is a repeat.
Oh, no, smaller size.
Is it?
No,
Smaller size.
no.
Cell matrix and FOV
Which
is
of
what?
the following will give you the smallest size pixels? So it would be the largest size matrix,
Yes.
and that would be, that one in the end, I believe is the largest, that 30 by 25 is the matrix, right?
No. It's the 29 by 29.
29 by 29.
Yeah, Nick was being tricky with this.
Okay.
Is that okay?
But I know it's the largest matrix.
That's
Yes.
right. So just multiply your matrix, find the largest value.
I forgot what I asked
That
last
was-
time. Smallest.
Okay, got one. Next question.
I just don't do the math.
I guess because if you did this, but this would be shorter.
But I
it
did
would
the
be
concept.
less pixels.
Which are the small?
Did you,
All right, so John, it's back to you.
IR is black.
Yes. Good, transmission, IR is black.
What's up, bud? Go on next, but he hasn't asked me yet. What's up?
Next question.
If SID, KVP, mass, and are unchanged, which of the following body habits will produce the most scatter radiation? Hypersthenic.
Yes.
Okay, good.
Did we?
Is that not a repeat?
That was the
No,
same that I
the
got
other one
last
Yeah,
time.
was-
last
The other
time.
one was absorption.
Okay.
oh, but I thought he got scattered last time.
No, I got absorption, but it was pretty much the same.
Mhm.
Yeah, because scatter and absorption. Almost. Except
Except for?
for atomic number.
Should be here next.
Which of the following will give you the largest number of pixels? The smaller the size, more pixel, right? No.
Yes.
Let's see, internet
Oh,
images.
smaller the
big-
size of what?
Like the
Big depth
matrix.
25, the second one.
So,
I think she was on the same right track.
Pixel, the bit depth, the more the bit depth,
That's contrast.
the, which of the following will give you the largest number of pixels? The more the bit depth, the more number of pixels, right?
no.
Remember what I said? Bit depth and equal shades of gray.
Or contrast.
Space, contrast resolution, right? Pixels, matrix, field of view is spatial resolution, right? So then we're not looking at, since we're looking for pixels, why are you looking at bit depth? You know what I'm saying? Like,
Basically,
we shouldn't look at bit depth.
So then spatial resolution. The bigger the matrix, the more the spatial resolution, the more the pixel.
The more numbers you have.
So which one?
So the bigger one is 25 into 25 matrix.
I may have wrote this one wrong. I don't remember.
Alright, so once again, as a review, right, when we are talking about the size of things, when you're talking about size, what variables should we be looking out for? Matrix, pixels, field of view, right? So if we're talking about size, right? Size of your pixels, size of your matrix, size of your field of view, right? Size, it's all about those three things, right? We're not gonna talk about size of your color, right? Size of colors don't make sense. So when we talk about shades, right? The shades of gray, the number of gray colors, right? That is going to be what?
Contrast.
That's contrast resolution, bit depth, right? So shades or grays or black or whites, anything dealing with colors is gonna be about contrast. Pixels, matrix, field of view, that's all about spatial resolution. It's all about size, okay? So make sure you don't mix them up, right? Because is it possible to have something small with different colors?
Yes, sir.
Yes, and you have something big with different colors, right? So size and colors are not connected to each other. They are independent. Size can change by itself, colors can change by themselves. They are not connected. So make sure you keep track of which one is which.
So is it, for example, maybe like a big picture is black and white, but a small picture has like 500 colors?
Mhm.
That can happen.
Yes, that can happen.
Okay, Angelica's next. Having a large matrix contributes to high spatial resolution.
Yes. So like said earlier, remember guys? Bit depth, grays, contrast resolution. Those three go hand in hand. And then yes, pixel, matrix, field of view, spatial resolution. Those go hand in hand. So if we're looking at matrix, you can already eliminate contrast resolutions out of here. So you're only left with low and high. And after that's a 50-50 shot, that's pretty good to me, you know, so you gotta like look at it. That's all I'm saying. It's better than 25%.
So the answer is high contrast resolution.
High spatial. We're looking at matrix. Pixel matrix. Okay. Does everybody understand? That's good. That's a good idea.
Chart is a good idea.
Okay.
Emily.
Yes. So the primary beam interacts with the patient. That's coming from the tube, hitting the patient, and then whatever the matter interactions goes on in there, and then the remnant beam comes out, hits the IR. Or the
Yay, we're done, Mr. Phung. Should we just?
Good job, guys.
Are you going to give us these?
We should just go.
It's in the. I sent it.
Oh, you sent it to us? Alright. John's got it.
I sent it.
Already,
Yeah.
what have you got for us?